Alright, I'm going to make this video to go through the speed and velocity tiered problems worksheet. Of course, the expectation is that you've been able to do most of this on your own, but I'm going to go through every single question. And on this recording, if you need to see answers on something, feel free to skip forward to the ones that you need, skip the ones you don't need. So, first thing, did you make sure that you only that you followed the options? Because you didn't have to do all the questions, just make sure you pay attention to the options. But let's start with level one. What's the difference between instantaneous velocity and average velocity? Remember that instantaneous velocity means in an instant, one moment. How fast is someone going that second, that millisecond? Right, whereas average velocity is over a period of time. So if you're driving from here to Atlanta and it takes you 30 minutes, then your average velocity would be the distance to Atlanta divided by 30 minutes. However, that doesn't mean you didn't have to stop at a red light. It doesn't mean you didn't have to slow down in traffic. It doesn't mean that you didn't go faster when you didn't see any police officers, right? It just means that over that period of time, on average, you were going that speed. It's kind of like on a quiz, you might get a 75, but your average in the class is an 80. By getting the 75, you're lowering your average, but that's not the same as your average. Number two, what's the difference between speed and velocity? Velocity involves direction. Speed does not. Calculate the average speed in meters per second of a cheetah that runs 140 meters in 5 seconds. Speed is distance over time. So speed here is 140 divided by 5. 140 divided by 5, let me do a quick calculate. 140 divided by 5 is 28 meters per second. How far do you travel if you maintain an average speed of 10 kilometers a second for 40 seconds? Speed equals distance over time. Let's plug in what we have. Speed is 10. Our distance is what we're looking for, and our time is 40 seconds. To get the d alone, we're going to multiply both sides by 40. And we get 400 meters equals distance. How fast? Ooh, none of that appeared there. Make sure you get a shot of that. How fast is a cyclist going who travels 40 kilometers in 1.5 hours? Speed equals distance over time. Speed equals, let's plug in the distance, 40 divided by time, 1.5 hours. Right, kilometers and hours. So 140 divided by 1.5 is 140 divided by 1.5 is 93 point, 93.3 repeating kilometers per hour. Kilometers per hour. All right, next, number 6. What is the velocity of a worm traveling 1 meter in 2 hours to the east? Speed, or we're asked for velocity. Velocity equals change in position divided by change in time. That's a triangle. So velocity equals, the change in position is 1 meter, and the change in time is 2 hours. So velocity is 0.5 meters per hour. Make sure we keep our units the same. Next, what is the displacement of a runner who's running at 0.5 kilometers an hour for 3 hours due north? We'll say velocity equals displacement over time. So 0.5 kilometers per hour is our velocity. We'll plug that in. We're looking for the displacement, so we'll just copy that over. And then the time is 3 hours. So we want to multiply both sides by 3 hours to get that out of the bottom, out of the denominator. So 3 times 1/2 is 1.5. These hours will cross out, and we get 1.5 kilometers is our displacement. Displacement, of course, has a direction, so we'll say north. Number 8. How long does it take for a cow to walk 100 meters across the pasture when she moves at 0.25 meters per second? So we'll say speed is distance over time. Notice we're just using speed here. It's basically the same formula, but we don't have a direction, so we can't use velocity. So speed is distance over time. We know her speed is 0.25, so we'll plug that in instead of the s. The distance is 100 meters, and we're looking for the time. Now, because the variable's on the bottom, the first thing we need to do is multiply to get the t out of the bottom. 0.25t equals 100. This is a very commonly missed mathematical step. Now, to get the t alone, let's divide both sides by 0.25, and we end up with t equals 400 seconds. Right, because 100 divided by 0.25 would be 400. All right, let's move over to the Quebec Racer. The Quebec Racer travels for 6 hours at 105 miles an hour. The Chicago Skyscraper travels for 8.5 hours at 92 miles an hour. Which train covers more distance and how much more? We need to do two calculations here, right? We'll do speed equals distance over time for the Quebec Racer. Let's make all this for Quebec. So we know 105 equals distance over 6 hours. 6 times 105. 6 times 105 equals 630. 630 equals D. This is all for the Quebec Racer. Now let's do for the Chicago Skyscraper. For Chicago, we have speed equals distance over time. Again, writing my formula first. The speed is 92 miles an hour equals distance over the time is 8.5 hours. 92 times 8.5 is 782. Distance is 782 miles. Miles. Okay, so which one went farther, 782 or 630? Clearly it is the 782. How much farther? Well, to get a difference, we subtract. 782 minus 630 gives us 152 miles more. All right. Number 10, if the West Coast Skyliner is traveling north at 120 miles an hour and the Skyliner 2 is traveling south at 120 miles an hour, do these trains have the same speed? Yes, they have the same speed, 120 miles an hour. Do they have the same velocity? No. Velocity involves direction, and in this case, one is going north and one is going south. Number 11, if the speedometer of a car reads a constant 40 kilometers an hour, can you say the car has a constant velocity? No. Can't you be driving in a circle at 40 kilometers an hour? Can't you be going around corners? Can't you keep your speed the same while turning the steering wheel? And because velocity involves direction, velocity cannot be guaranteed to be constant even if speed is constant, unless we know that it's going in the same direction the whole time. Let's do some of the graphing questions. Now, these really are meant to be after you have done the CARS lab, the tumble buggy lab, and maybe even looked over the notes from Tuesday. Okay, level 1 graph questions. Calculate the average speed of the object during the first 3 seconds the object is in motion. To get the speed on a position time graph, we need to get the slope of the line. Let's get the slope from here to here. Rise over run. So delta y over delta x equals slope. So let's plug in. Delta y would be 20 minus 15, new height minus old height, divided by the change in x. The new x is 4, the old x is 3. So that'd be 5 over 1, so 5 meters per second, taking the units from our graph. 5 meters per second. Notice that because it's a constant line, we could do the slope over the entire area if you want. So we could do 25 minus 0 divided by 5 minus 0. 25 divided by 5 would also give us 5. Calculate the average speed of the object during the seconds 2 through 5. Well, we already know that. That's 5 meters a second. We just figured that out, right? 2 through 5. That'd be 25 minus 10. So 15 divided by 5 minus 2, 3. 15 divided by 3 gives us the same 5 meters a second because it's a constant slope and therefore constant velocity. What does the slope of the position time graph represent? That is velocity. Describe what motion of the object would look like during the first 5 seconds of motion. It's moving at a constant speed. Constant velocity. What about the between the times of 5 and 10 seconds? Well, because it's a horizontal line, that is stopped. Right? Because it's at the same position at 5 seconds as it is at 6 seconds, 7 seconds, 8 seconds. It's always at the same position. That means it is stopped. Let's go to level 2 questions. In the qualifying round of the 50-yard freestyle in the sectional swimming championship, Dugan got an early lead by finishing the first 25 yards in 10.01 seconds. Dugan finished the return leg 25 yards in 10.22 seconds. Determine Dugan's average speed for the entire race. Well, isn't speed simply distance over time? So speed equals the total distance he went, which is 50 yards. 25 plus 25 is the total distance, divided by the total time, which is 20.23 seconds. 10.01 plus 10.22. 50 divided by 20.23. 50 divided by 20.23 gives us 2.47 yards per second. Determine Dugan's average speed for the first 25-yard leg of the race. All right, we'll do it the same way. Speed equals distance over time. So speed equals the distance, which is 25, divided by the time, which is 10.01, and 25 divided by 10.01 is going to be like 2.5. 10.01, yeah, 2.4, yeah, 2.5 yards per second. All right, C, determine Dugan's average velocity for the entire race. 0. Why is it 0? Because velocity depends upon displacement. And remember, because Dugan started and ended at the same point, his displacement is 0, meaning the velocity must be 0 because 0 divided by anything is 0. Sound travels at 330 meters a second, I guess if the air's a little thin. If a lightning bolt strikes the ground 1 kilometer away from you, how long will it take for the sound to reach you? So, speed equals distance over time. Always write our formula first. 330 plugged in for the S. Distance is 1 kilometer. Now notice, this is in meters per second, and this is in kilometers. We don't want to mix units. So how can we change that kilometer into meters per second? Well, a kilometer is 1,000 meters. So we'll divide that by time. Now, we're at that position again where we have time in the denominator, and we need to get it out. So the first thing we do is multiply both sides by t to get the t out of the denominator. 330t equals 1,000. Divide both sides by the 330. And we get that t equals somewhere around 3.03 seconds. Yeah, we don't have that many sig figs, so we'll just say 3 seconds. All right, you and a friend each drive 50 kilometers. You travel at 90 kilometers an hour. Your friend travels at 95 kilometers an hour. How long will your friend have to wait for you at the end of the trip? Okay, so we'll do speed equals distance over time for you, and speed equals distance over time for your friend. You, friend. Okay, so you're driving at 90 kilometers an hour, and you're driving 50 kilometers, and so how long does it take you to get there? We've got the t at the bottom. We got to get it out. Cross that out, and we get 90t equals 50. So t equals 50 divided by 90, which is 0.56 seconds. No, 0.56 hours, sorry. Your friend is moving at 95 kilometers an hour equals the distance of 50 kilometers divided by some time in hours. Again, we'll multiply both sides by t to get it out of the denominator. 95t equals 50. Divide both sides by 95. And we get that t equals 50 divided by 95.53 hours. Okay, next, Ken Run Fast. Ken Run Fast is the star of the cross country team. During the recent morning run, Ken averaged a speed of 5.8 meters a second for 12.9 minutes. Ken then averaged a speed of 6.1 meters per second for 7.1 minutes. Determine the total distance which Ken ran during his 20-minute jog. So let's do two equations. Speed equals distance over time for time 1, and speed equals distance over time for time 2. Okay, he averaged a speed of 5.8 meters a second for 2.9 minutes. Now, I'm sorry, 12.9 minutes. Now we're doing meters per second, so we can't use minutes here. So we need to convert those minutes into seconds. How do we convert minutes into seconds? We'll multiply by 60 because there's 60 seconds in a minute. So we'll take our minute, 12.9, multiply by 60, and we end up with 774 seconds. Multiply that by the 58 meters a second, and we end up with 44,892. Meters. There we go. 44,809. That's 44 kilometers. Whew. That is a long way. That's why, because there's a decimal there. That's 5.8. Got to be careful with that. So multiply that. We got to move this decimal over 1. So this would be 4489.2 meters. 4,489.2 meters. That makes more sense. He ran 4 kilometers in the first 13 minutes. He is quick. All right, let's do the second time. He is running at 6.1 meters per second for 7.1 minutes. So 7.1, once again, we need to convert it into seconds because we're doing meters per second, and we can't combine seconds and minutes. So 7.1 minutes, 0.1, multiplied by 60 gives us 426 seconds. Multiply that by our speed of 6.1, and we end up with 2,598.6 meters in the next 6.1 seconds. He is quick. All right, determine the total distance which Ken ran. Well, this distance plus this distance would be 7,087.8. Car travels 200 meters east, 400 meters west, and then 800 meters east again. It does this in a time of 100 seconds. What is the car's average speed? Well, we now take the total distance divided by the total time, right? Because it's speed, we don't care about direction. So 200 plus 400 is 600, plus 800 is 1400. 1400 is the distance divided by the time, which is 100. We'll cancel out our zeros, and we end up with 14 seconds. 14 meters per second. Okay, what is the car's average velocity? Well, now we need to consider direction. So what's the total distance east he went? 1,000 meters. But then how far did he go west? 400 meters. So what's left between here and here? Wouldn't this be 600 meters east? So from the beginning to the end, he ended up 600 meters east of where he began. So let's do velocity equals delta x over delta t. Velocity is 600 meters because We had to subtract the 400 from the 1,000 because it was going the opposite direction. He ended up 600 meters from where he began, so it's displacement divided by the time, which was 100 seconds. Cancel out our zeros, and our velocity is 6 meters per second. Notice, sorry, that was all off screen, wasn't it? Notice that the velocity was 6 meters a second, but the speed was 14 meters a second. That's because the speed considered all the distance moved, whereas the velocity considered the displacement alone. Level 2 graph questions. During which time interval does the object have the fastest motion? Well, the fastest motion is the steepest slope. There it is. Describe, and so that's between 0 and 10 seconds. Describe the motion of the object during the following time intervals. 0 to 10 seconds, it's moving in the positive direction. 10 to 15 seconds, it is at rest because it maintains the same position at 60 meters as time goes by. 15 to 30 seconds, it's moving in the negative direction. That means it's moving the opposite direction. And then D, from 30 to 40 seconds, it's still moving in the reverse direction, in the opposite direction of where it was moving initially. That would be negative velocity. Number 23. Does the slope of the graph above represent the speed of an object or the velocity of the object? The answer is velocity, because a negative slope gives a different result than a positive slope, right? This is different than this. This is different than this. These, if they were speed, then negative wouldn't be a thing because we couldn't worry about direction. And number 24, what is the total distance the object travels? What is the total displacement? So the total distance, all we have to do is add up the total distance he moves. So he moves 60, so we'll do 60 plus, then he goes from 60 to negative 40. So 60 plus 40 is 100. And then he goes from negative 40 to 0, so that's another 40. So the distance is 200, is it in meters? Meters. But our displacement is going to be different. For displacement, we have to say from here to here, in the first 30 seconds, doesn't he end up right where he began? Back at 0? And then from 30 to 55 seconds, he ends up back at 0. In fact, from 0 seconds to 55 seconds, he ends up in the same spot. So what's his displacement? 0. Ended up right where he began. Hopefully that was helpful. If you need more help with any of these questions, make sure you ask in the live session or ask me individually.